Today we are going to learn how to make C++ compiler write codes for us when needed. So we don't have to write it. Okay? So we're going to give the instructions of the logic of the programs we are using. Logic of the program we are writing. We're going to give it to the compiler. Tell to the compiler whenever you need it to create a function, use this logic to write a function for me. So essentially, the compiler will write the function for you. So when you write this type of logic, if you never call a function, it's as if you didn't write anything. Compiler will not generate any code. So the difference, essentially, it is like overloading. When you are using overloading, you create 5 different versions of the same function with different argument lists, correct? And whichever is called, compiler matches to the proper signature and calls that one, right? When you are creating what we call a template, instead of creating 5 different versions of the function, you create only those, like if instead of creating, like say you have a function created to do some kind of a program, whatever that is supposed to do. And the prototype for these functions are different with different argument list. And the logic of half of them are the same, and the logic of the other half are the same too. Which means you have 2 categories. They're all overloads. You have 20 functions. Out of these 20 functions, 10 of them follow the same logic with different types. Another 10 follow a different logic with different types. And therefore, whichever you call, it's going to be called and it's going to be executed. That's overloading is, what overloading is. We learned it at the beginning of the semester. With templates, instead of writing these 20 functions, you write one logic for all those who have the same logic and another logic for another version of it. And compiler will not generate any function for you unless a function is called. So if you have a function called, compiler will match the ID of your function, the signature of the function, to the template. And if it is a match, at compile time, it will create a function for you. The difference between templates and overload is that for overloading, you have to plan for all different types of call that you can do for a function and write them all. And when you compile, they're all going to get translated into binary and compressed in your executable. So if you have 20 different calls, you are going to have 20 different functions, even if you do not call any of them. Like every single library that you add. With templates, you create the logic, and only those functions who are called will get created. Therefore, if you don't call any of them, your executable will be very small. If you call all 20 of them, then 20 different functions will get created for you. This makes programming much more efficient and also creates lots of flexibility. This type of polymorphism, where actually compiler creates the code for you based on the logic you provided for the compiler, is one of the best examples for polymorphism. With overloading, it is not really polymorphism when you look at it closely. When you really look at it, the functions, they do have the same name, but the arguments are different. So if you have a function that adds 2 integers, you have add int. Then you have another function that gets 2 doubles, it's add double. So the names are not really the same. They tell us they're the same because the name of the function is the same, but the compiler actually brings the signature of the function into account. But with templates, it's not like that at all. The function doesn't even exist if you don't call it. the function will get created based on your call. Let's look at what I just said about add functions. So if I really want to add few things, let's say I want to add int add int a int b. If I actually have something like this, I'm going to say return a plus b, right? Silly function, I know. There's no need to create a function like this. It's just an example. Are we okay with this? If I want to overload that, I'm going to go double add, double d and double l. And in here, I'm going to say return d plus l, right? If I want to, let me pause first. So, yes. So now, thank you for that. Imagine that I have a class called container, just for example, okay? And that container has a property called data. It keeps the data, and you can set the data using the default constructor. And it has an operator plus binary created for it, which essentially returns a container that the capacity is the sum of the two. Okay? You can print it like C in and C out. So if I want to, frankly, I can actually write an add for this one too. I can say container, add, container, C1, and container C2. And I can say return C1 plus C2. Why? Because the plus operator is defined for container. So take a look at these three add functions. These are all different add functions that are overloaded over and over, right? So, and if I write a main for it to actually, so I'm going to actually add yet another function over, another class over here. I'm going to call that class mark. Mark is exactly like a container. It has a data of its own, and you can set the data. The only difference is that the plus just doesn't add the two things, because it's a mark, right? It cannot be more than 100. So when you add the two, if it goes more than 100, it sets it to 100. Otherwise, it's going to set it to whatever it is. So mark is another thing that has an operator plus between the two. So I can even use it for that. I can even actually have something over here, something like, whatchamacallit? So I can have another thing in here called mark, add mark M1 and mark M2, and return M1 plus M2. So I can actually write a main program that calls these things and tests them. So say I have a main over here. I'm creating a double, two double values, three doubles, of course, 1.1, 2.2, and a Z. And I have three integers, three marks, three containers. And I'm calling the add functions for all these things. Are we okay with this? Very simple, straightforward. And if I run this program, obviously, the program is going to run, and it's going to call the add. Oh, it's going to give me an error. Let me see what do we have in here. Oh, I already have a main somewhere. Yeah, sorry, two mains. All right. So as you see, the sum of two integers are calculated, and that's 3. So sum of two doubles, sum of two marks, and sum of two containers. Right? Anybody have any problem with this? Are we good? So this was overloading, right? Functions. Now, imagine you have someone who has no idea how to write a C program, and you want to instruct them to create similar functions if needed. let's say I didn't have these things. Okay? Let's say I didn't have these things. And I want to tell somebody to write a function that follows that logic. So I would say your function should return a type. It's called add. It should receive a type, A, and another type, B, and in return, it should return A plus B. Correct? That's the logic of all these things. Do we agree with this? So if I change the types over here to int, I'll get the first one, correct? If I change the types over here to double, I'll get the second one. If I change the type over here to container, I'll get the third one. If I change the type to add, I'll get the third one. And I'm done, right? You can do that. You can actually tell to the compiler, hey, this is a template. And the type name is type. Done. By saying that to the compiler, you are telling the compiler, if anybody is calling an add, take a look at the signature of their add. In here it says add I and j. I is an integer, j is an integer, right? So at compile time, it will generate this function for you. You will have an int add, int a, int b. Then you call over here a double for x and y. It's going to get created. And based on every single one of them, it's going to run exactly the same. Ta-da. So you don't even have to overload the function over and over and over. You just write the logic that is common between all the things that are supposed to be done. You put the type that you focus on over there, just for it to make sure that everything is done properly, and it writes it for you. Are we okay down to this point? So let's look at this and make this a little more interesting, because this add thing is silly. Like, who wants to do that, right? One of the most important things that you do in computer science is when you actually want to sort stuff, right? So when you want to sort stuff, what you do, you need to actually write some kind of a code to rearrange an array of things and set it to something, right? And organize them in an orderly fashion. So this one is going to be a templated function. So I'm going to let the container be. I'm going to let the mark be if I want to use it for something later on. And this operator, yeah, it's for mark. Let that be. And I don't need this add thingy. I'm going to remove it. And in here, I'm going to take this out. And so if I want to have some kind of a function that sorts stuff, okay? What do I need to do? Let me just see if I can actually find over here what I had. Where is it? Did I? Okay, give me a second. I'm going to pause it. Okay, say I have an array of integers, okay? And I want to sort this array of integers. So the ideal function for this will be something like sort, and I'm going to pass the array to it. Tell to the sort that I have 13 of them, right? Any problem with that? I can even tell to the thing, that's okay actually, sort. And then after I sort, I want to print that the elements of the array. So I'm going to say prn array, and I'm going to put a and 13. So that's going to print the array, and then I'm going to go to new line, something like that. Okay, so this is what I want to do. I want to be able to sort the array and then print it. So that's what I want to write. So sorting We already know. We've already done it in IPC144. We had it in the thing. So I'm going to do bubble sorting here. So I'm going to say I have a void sort. And the sort that I have over here will have a size T, I, and J. I and J. That's for sorting. Then I'm going to say for I set to 0, I less than size. Sort needs integer array. Let's call it array. And let's put like that. And I need the size T size, right? That's what we wanted to do. Size. And size -1 and I++. So I'm going to do this sort like this. So it goes from I, goes over there. And then I'm going to have for J set to 0. And J less than size minus I -1 and J++. Now in here, I'm going to check the value of the neighboring elements. I'm going to say if array J is, say, greater than array J plus 1, then I'm going to swap the two, swap the value of the two. So I'm going to write over here swap what I have in this one and what is sitting in the address of this one. Are we good with this? And swapping is very simple. So I'm going to write over here void swap. In here, going to be integer pointer A, integer pointer B. And I'm going to have over here integer temp set to target of A. Then target of A is target of B. And target of B is temp, right? Are we okay down to this point? Problem? No problem, hopefully. Okay, now the only thing that is remaining is that print array thingy. So in here is going to be std, ostream reference prn array. And, yeah, prn array. Yeah, and I'm going to have an integer array, constant integer array to print. And I'm going to have size T for size. And then I'm going to have the std ostream reference ostr to print that thing on. Are we okay with this? Are we okay? So these are all review of the things that we know, right? So for this one, I'm going to write for size T, I set to 0, I less than size, and I++. I'm going to print the array element, right? And then after that, I'm going to say if that I thingy is not equal to size -1, not equal to size equal to size -1, then I'm going to print a comma to do to my, not cout, ostr. I don't know why it compiled. ostr. And return ostr. So I think I'm good. So it's going to make it comma separated. Let's take a look at it. So I'll start from the beginning, go up to size. One by one, I'm going to print the element of the array. And if this is not the last one, after printing the array, I'm going to put a comma. Are we good? Here, literally IPC144 stuff, right? Other than cout and ostr that we are using. So if I run this program, that array of mine over there that you see, and why is it doing that? Oh, because we need to, equal to std cout. So we don't have to add it over and over, right? So if I run the program, 3 years later, everything's sorted in ascending order. If I want it to descending order, what do? I do it like this. I don't know why that thing happened. I do it like this, and it's going to print it in descending order. Are we okay? So actually, let's do that. Say in here, I'm going to say Boolean ascending set to true by mistake by default. And in here I'm going to say if ascending, do this, otherwise do this. You can make it in one line, but I just want to make it quick. That's why I'm doing it like this. I'll make it efficient later on. So now it works the exact same way. The difference is that if I don't want it this way, I can come over here and make the sort descending and go false over here. And now it's going to come out in descending order. Are we okay? All right. All right. I want to sort anything, not only integers. Logic is the same for all of them, right? So all I need to have, so for this thing, for this sort of mine, first of all, let's convert the sort. So remembering from the last thing that we have done, we had a logic, right? All we did, we put a template type name type, and we put the types that are the focus of my attention to type so it can change, right? So in here, I'm going to do the same thing. For this sort, so let's actually save this over here. I'm going to say over here, C sorting ints. And come back over here. So now, so you know what it was beforehand. So now, if I want to convert this, the very first thing that should be converted is swapping, right? I should be able to swap the value of any two things. So in here, I'm going to say template. Okay. In here, either you can say type name or you can say class. Class is old C++. Okay. But it's backwards compatible. So you can actually say class type over here or class doesn't matter. Okay. But just remember, if you see class over here, it's the same thing as type name. They just thought type name is an appropriate thing to say over here instead of class. So it is, I'm going to put type name. Okay. So type name all right. And so what needs to be in here? So the reason I put is that don't think that you have to put name type over this. So let me change it. Instead of I'm going to change it to T. Okay, so what needs to be replaced? Line 35. Line 35. What needs to be replaced at line 35? Void swap, and then I should change something over here to T. The thing that is supposed to get swapped. Int. So it's int. So the first thing is over here. So I have to say this should be a T, which means when an integer comes, it's going to be integer pointer A, right? And the other one is integer pointer B. Now, next one, what do I need to change in the function?
Temp, the integer temp.
Integer temp, exactly. Keep it for now. Okay, that's fine. Just
to T.
Yeah, so we're going to change that to T, right? Which means now it's templated. We don't need to actually convert sort yet. I can simply test it and see if it works or not. Okay, so in here I'm saying address of an integer, and in here I have address of a type. So compiler will create the swap for me, and if I run it, it will still work. Right? Obviously, I'm going to take this out and make it ascending so sort looks more interesting. Correct? Good. All right. So now we're going to do the sort. So I'm going to go to the sort. All right? So if I want to change the value, if I want to make the sort template, first of all, the template that you are writing only affects the scope that comes after. Okay? Which means if you wanted this template to come down here, if you put it over here, then you have to put a prototype at the top, right? the prototype for a template is written like this. You still have to make it a template. It's because this template only affects the thing that comes after. And now this template is affecting this one. So this essentially becomes a prototype for a template. Are we okay with this? So now if I want to do the sort in here, I'm going to say template, type name. Somebody help me type name T. And, okay, my friend, line 39. Do I need to change anything to T over there?
Yes, the array type.
So the array type should be T.
Yeah.
What else I need to change?
For 39,
Yes.
nothing.
Nothing. That's beautiful. We can give it to my friend over there. Nothing needs to be changed. Nothing needs to be changed. Why? Because I am sorting an array. The focus of the attention in here is on the type of the array. When the array is being sorted, if it's an array of containers, 5 containers, it's still 5. The number of containers won't change. The direction of sorting won't change. It has nothing to do with what I want to convert to a template. Now, tell me, look at anywhere else in here and see if anything needs to be changed.
I think nothing needs to be changed.
Nothing needs to be changed. He's right. So nothing needs to be changed because in here I don't have anything that specifies anything special. So now if I actually run the program, we will see that it still sorts as a template. Now, what are we going to do is this. May I have that thing? Yes, my friend. This is good. I'm going to have to walk, right? So, go. Sing for me. What's up?
I had a question.
Go ahead. Yes, I know. That's what.
Repeat the point that you were saying.
The what?
The point about why you don't have to change
Anything else? Yeah. Okay. So when you are actually, you can actually give the microphone to your friend over there because it's going to be his turn. Okay.
Right.
So when you are changing, when you are converting, usually when you're a beginner, when you're a rookie, you're a beginner. When you want to write a template for a function, first you write it for a general type. So if you want something that sorts everything, first you sort an array of integers. And then you convert that to a template. Later, when you are expert in it, you can start writing a template from scratch. But why we don't need to change size t or bool over here? Okay? Why? The answer is this. If you wanted to rewrite the sort to sort array of cars, what would you have written? You would have written void sort car array, correct? Would you change size t? No. 5 cars, 5 integers, 5 hospitals, 5 chairs. 5 is 5. It doesn't need to change. Now I want to sort the cars in an ascending format. Do I need to change it? No. Sorting the car in ascending is sorting hospitals in ascending, is sorting chairs in ascending, is sorting students in ascending. They are all the same. Therefore, you don't need to. So your trick when converting a function into a template is to see what is the focus of the logic and make that a type and leave the rest be. Do I make sense? All right. So, another template we have to convert. Print array. I want to print anything in a comma-separated thing. So in here, I'm going to say template. Type name, type. So, my friend, line 65, what do I need to change to type?
The array.
Constant or int? See, that's a tricky question. Should I remove constant and make it a type?
Only int.
Only int, yes. Because any array that I want to sort, actually that's wrong. Oh, no, any array that I want, that's actually correct. Any array that I want to, because I said sort, then I heard sort, and it's not sorting, it's printing. Any array that I want to print, I don't want to change. I just want to print. So it has to be, you can give the microphone. So,
Aye.
so you know you're the next person, and then it's going to come forward. Okay? All right. And if you don't want to answer, just pass the microphone to the next person. Okay? So in here, I'm going to change this to the type. Okay? Do I need to change line 66 in here? To anything?
No.
No. Okay, but keep the microphone because that no was very short. I want to ask you a very hard thing in a second. All right? So now if I run it again, it will work perfectly. All right. So let's try it with something else now. Now that we have this, I'm going to have myself an array of doubles. And let's see if this thing can actually sort an array of doubles. So this is double. I'm not going to change anything. I'm going to say sort D, 10 of them in descending order. Okay? In descending order. And I want to print them. So prn array D and 10 of them. And then go to new line. And I compile and run them. And poof, that is sorted too. Not only that, let's actually do something else. So let's say I have a class called name. Let's say I have a class called name. Oh, these are mark stuff. Let me just bring them down, 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 and bring the name. Name, right? Oh, I need utilities. Darn it. Add existing item. Existing item. Pause again. So this name has dynamic memory allocation in it and rule of three applied and everything. It has default constructor. It has copy constructor, copy assignment, a virtual destructor. It has an operator plus to add one name to another name. It has operator greater than, operator less than, display, and all the whole 9 yards. It has everything set up for it, and it can be displayed. So what I can do now, I can simply come over here and create myself an array of names. Okay, which are 8 of them. Now in here, I'm going to say sort n 8. Let it be ascending, and then print the names in comma separated thing. So I'm going to say prn array n and 8. And if I run it, you'll see that magically the class is actually sorted in a perfect ascending order. Are we okay with this? Because that's your turn. Get ready for this. Okay? Why it sorts it perfectly in dictionary order? Because that's how its operator greater than is implemented. So the operator greater than in name does string compare, and less than does string compare. Okay? Now let's sort some marks. Okay? So now what I'm going to have, I'm going to create some marks. So I'm going to say mark over here M, and I'm going to put few marks in here. Say 50, 88, 45, 32, 100. That's enough. Okay, 5 of them, right? So I have 5 marks over here. That is 5, right? 1, 2, 3, 4, 5. Yes. So now in here, I'm going to say sort M5 and I'm going to print them. Now I'm going to say prn array m, what is it, 5 and L, and then I'm going to compile, and poof, failed, didn't work. What's the reason for this? The reason is, and if you go to error list, it says binary, you see binary greater than, T does not define this operator, or yada yada acceptable, yada yada. So it writes something, it gives you an error for your template in sorting. Your template doesn't have an error in here. Go to the output and check what the output of the compiler is. And over there, with 5 million things that you see over there, come to the first one, and the message over here would be this. I'm just going to bring the message over here so it's bigger, we can see. It says, error yada yada yada, binary T does not define operator to a type acceptable to the defined operator, and it says with type being mark. It means the mark object is not defining greater than operator. So sort cannot sort it. You follow what I'm saying? So you can create templates with the logic that you want. But if the class you are putting in there does not support all the aspects that your logic is using, the template may fail like this, which is the perfect scenario, or crash your program without you even knowing why or where. That's why every single template must come with a documentation explaining what features the type in this template requires so the template can work. You have to put that one under extreme scrutiny. What does that mean? Put it under microscope and walk through it step by step. That's your turn. Okay? So, forget about sort. Let's start from the beginning, and we're going to document the first one, that is our swap. Okay? So to document it, I'm going to bring the swap up beside its prototype. Why does it give me an error? Okay. And then put 3 slashes over here. 1, 2, 3, and poof, that happens. Right? So it tells us all the things. But forget about those things. Just take a look at here. Tell me, what T needs to have in here for it to work? What do you think?
Inside a function or?
Everywhere. So you look at the first one. I'm going to guide you with the first one, and then you do the rest. The first place that you see is T pointer A. You have to think, can any type have a pointer? Or there are some types that they can't have a pointer. No, any type can have a pointer. I can have an employee pointer, car pointer, I don't know, chair pointer, student pointer, integer pointer, double pointer. I can even have an integer pointer pointer. There is no problem with that. That's a double pointer. I can have that. So there is no problem with that. The same thing with the other T. At line 93, T pointer B. No problem, it's a pointer. The next occurrence of T is line 94. What does T need so it can actually work? What is happening at line 94? Can you analyze it for me?
On the line 94, the T temp, the type name temp is assigned to the pointer A, which is...
Don't say pointer.
Yeah.
So wait. Just, I'm correcting your phrase. Line 93 is T pointer. This is target of.
Yeah. The A, which is points to the integer. Integer which is...
To an object.
To an object.
So what does it need? What T needs for that thing to run?
pointer, I think.
No.
No.
No, no, it's very difficult. For the first time, if you actually say it, you already either already studied it or you're a genius. So don't expect to answer it, okay? But what do you think? Huh?
Can I guess?
Of course.
Reference? No. No.
So just think about this. Type A, type B equals A. What does type need? That's what's happening here, right? This is what's happening here. Because target of A is a T, correct? You are creating a T out of another T. What is required to do so? I want. No. No, assignment at the moment of, we can give it to the next person. Assignment at the moment of creation is what?
We need to have the same type.
Yes, but what is assignment at the moment of creation? Don't look at that. Assignment at the, what is assignment at initialization?
So we put some.
No. What is it? What is it? Yeah. What assignment? You know what it is? I've mentioned this 50 times. What is assignment at the moment of creation? Is assignment at the moment of creation an assignment operator? Sit. Assignment at the moment of creation. I know you know it. That's why I'm not going to answer. I'll let you answer. I want other people to struggle and think. Assignment at the moment of initialization. What is it? Yes! What does it do? So creating a new variable. How do we create a new variable? With what? With a key. No. How do you create a new thing? What is called when something new is created? Constructor! Thank you. But what type of constructor? Assignment constructor? You're right, actually. What is assignment constructor? Kill me now. Copy constructor! First, remember, assignment at the moment of creation is always a call to a constructor. It is not an assignment operator. Assignment at the moment of creation is a constructor. That's number one. Number two, what type of constructor? You should see what is the type in front of the assignment. The type in front of the assignment is a T, right? It's not a T pointer, it's a T, right? Therefore, you are creating a temp out of another T. Therefore, copy construction, right? So in your documentation, you have to mention over here, T must be copyable. Otherwise, this program is going to fail. Swap is going to fail. It's going to have memory leak and lots of other problems, right? I think it's your turn. All right? So, line number 98. What does it need for that thing to work for everything? First explain what is happening. Like to a 7-year-old.
Assign it to A.
One thing is being assigned to another thing, correct?
Yeah.
Are the type of the two things the same?
Yeah.
So when two things are being assigned to each other, what is called?
Copy assignment.
Copy assignment. Thank you. So T must be able to be assigned, or copy assignment for T. Copy assignment for T is needed. Okay? Do we have anything else in swap? Line number 100. Is there anything in there? No, it's the same thing. It's assignment, right? So, done. Swap is documented. Obviously, you're going to say over here, primitive Oh, you got to say the type, template type, type name T, any object. Oh, object type. A is going to be, I don't know, address of object to be swapped. And the same thing over here again, address of the object to be swapped. Right? And now, when someone goes over here and brings the mouse over here, it explains exactly what it is. So template class T, type yada yada, T must be copyable, copy assignment for T is needed, parameters yada yada yada, and you keep going like that. If you want it to be in a new line, remember this is XML. I think if you do this, it's going to actually go to new line. So now if I bring it over here, it didn't work. I thought new line would work. It didn't. So comma. And so it's just one statement. All right? So that's that. Are we okay? All right. So now we're going to go to sort. Oh, baby. That's going to be... Milady, your turn. You know what would be interesting if it was off. There we go. All right, so we are looking, so we want to actually document this and see. I'm not going to write the whole thing over here. I'm just going to write the summary, okay? So starting from sort T array, yada, 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 whatever I have over there. For the T that let me just make sure, compile and make sure that I didn't break anything. Oh, I did break it. Mark doesn't work. So we'll go there. So now for sort T that we have, okay? The very first thing that I have is an array of type. Can we make an array of anything? Yes. Therefore, there is no need for any documentation for that. You can create array of any type. Good? All right. So line number 112, we don't have any variable of type T, correct? We don't care about it. 113, nothing. 114, nothing. 115, nothing. 116, oops, I have array J. That is of type T, and I have array J. That is of type T. So I have a type greater than type. What does that need? What do we need? What do we need to have for that thing, for T to be able to compare to another T? What needs to be implemented over there? If you can just pass it to the gentleman behind you. It is on.
The operator overload. For
The operator overload. So the operator greater than should be implemented. You can give to the gentleman back there again. All right? So operator greater than should be implemented. So we need to have over here T greater than T must be defined. And, okay? Again, swap, 117 swap. Can I get address of any type?
Yes.
Yes, I don't need to document that. Perfect. Keep it. That yes is not enough. Okay, 121. I have T less than T. What do we need? What needs to be implemented here? What needs to be implemented here? Operator less than, right? Operator less than. So we need to have, so T less than T, T less than T. So I'm going to say over here, and T less than T must be implemented. And the rest, there is nothing else. And because my mark does not implement the 2, it cannot be sorted. Therefore, if I want my mark to actually work, for that, I have to say bool operator less than const mark reference m const and greater than. And in here, I'm going to say return m data being less than m dot m data. And here, return m data greater than m dot m data. If I compile and run, now mark can be up. Are we good? Are we okay? All right? So now we understand. And I'm going to tell you what is one of the questions of final test that you have, final assessment. Give me 2 seconds. I'm going to give you a function, and I'm going to tell you what features are needed for this template to work. You need to be able to say that. You need to be able to analyze it and tell me that. You can give it to me. All right. Do we have any problem down to this point? Oh, you had a question. Oh. Take it.
You also mentioned before that we got to create a copy constructor for T, like TNT, but you didn't do this, and it still works, right?
Yes. But Mark doesn't need a copy construction because it doesn't have. Name did need it and had it.
Oh, makes sense.
Okay, so the one, so it doesn't mean that you have to implement rule of 3, but it should. The rule of 3 should oh, another thing that actually we forgot to mention was in swap. We did not mention it. It was a very bad thing. Because, actually, no, it doesn't need it. Because I have a local variable that's got to get known. Anyways, so when you have stuff like this, must be copyable, because you simply can say T must follow, T must support rule of 3. Easy, okay? It must support rule of 3 and everything's fine. Are we okay? So that is that. Just trying to see if any questions? Suggestions? Objections? All right. All right. So, next thing. Yeah, so let me just save this as, so C dash templated sort.cpp. Next thing I need to talk about is this. In the other class, I assumed that you already have this knowledge from IPC 144, but many did not, so I am explaining it here anyway. How the compiler works. So, what you see right now over here is assuming that I have executed the following command. What I have over here is assuming that I executed, I can actually type stuff over here and do things. Insert text into image. Woo, nice. All right. This assumes that, let me see. Yeah, nice. Let me see if this is the first time I'm doing this actually. Format is, I have no idea what the devil that is. Pardon me? Was somebody talking to me? No. I wanted to see a transparent section. No. I don't know. It's actually a little too rich for my blood. Does it work? No? Okay, forget it. What did I do? Okay. Okay, Control Z. I don't want it. Forget it. I have to learn it later on. Seriously? Okay, let me just take it off. Don't save. Bring it back up and just talk about it. All right. So I'll do it like this. So I'm going to say, this assumes that we have the following executed. Let me just, the following command is inserted. So this assumes that you have done something like this. You have done G++, 1.cpp, 2.cpp, 3.cpp, main.cpp, enter. Okay? This picture shows that command. Okay? Got it? Everybody knows what I wrote over there, right? All right. Okay. So the point is to tell you so it's going to be how compiler works, C. Oh, I have two C's. Let me fix that first. That's a D. And this is going to be E. How compiler works command. Okay, .txt actually. Let me see if I can actually make it convert it to a TXT. Yes. Save. So, and now I can actually remove all the gibberish I have in here that I do not need. Oh, wow. Okay. All right, and I'm going to bring half of it down so it occupies less space. But that's the command that I'm executing. So now I can see. All right. So for any time that you issue a compiler command, the number of modules that you see on the compile command, each file, I call it a module. Okay, so each file that you put on a compiler command, that's the number of times the compiler will be executed, separately, independently. So when you say G++, 1.cpp, 2.cpp, 3.cpp, main.cpp, it's as if you did G++ for 1.cpp. It ended. Then you did G++ for 2.cpp. Ended. And you did like that 4 times back to back. Then a program called linker is called to accumulate the output of all those 4 commands into an executable, which is the program you're running. Do we understand this? All right. Now, how it happens. So each compiler, each file is compiled as if the other ones don't exist. And the result is an object that is object file that is created. If you look at your Visual Studio, you see the name of the files .obj, or if you compile your code using -C in Linux, you see something's going to get created that .o. Instead of .obj, it's going to be .o, which means it's the object file. The object file is the binary translation of the C code that you have written by compiler. Do we understand that? And the compiler doesn't exist if all the other 3 exist. So take a look at 3.cpp, the green one. When you compile 3.cpp, as you see in header file of 3.cpp, the header file of 2.cpp is included. Do we understand that? Okay, which means when compiler is compiling this, When compiler, I'm just taking a chance to do this. When compiler is compiling this, what compiler compiles is this code. Do you understand that? Because it's included, and we know include is essentially copy and paste, right? So when something is included somewhere, it literally copies the code in that place and then compiles, right? So if 3.cpp is calling one of the functions of 2.cpp, the source code of the function is not available at compile time. Only the prototype is available. Do we understand this? Do we understand this? And that's really what all the compiler needs. Compiler needs to know how to call a function to generate its code. It doesn't need the function itself. You follow that? So it's like me telling you, there is a tutor down in Learning Center, you can go ask questions. That makes everyone happy. I just compiled your need for help. You told me, Fardad, I need help. I said, at 2 o'clock, I'm going to be on Microsoft Teams to help you. That's me giving you a solution for your problem, and I compiled your problem. You're happy. What is the executable doing? Executable is you actually going to the computer at 2 o'clock, see if I'm there or not. That's the linker. Okay? So when you are compiling, compiler only looks at the promises you made. And if everything is good, it compiles and generates the object file for you that is 3.cpp here. And it does the same thing for 1.cpp, 2.cpp, and especially for main.cpp that is including everything else. So when main is being included, actually, when main is being included, this is, when main is being compiled, this is what's being compiled. All right? After all the compilations are done and function calls are made and everything is done, the linker puts everything together. Linker goes through your object files and looks at your function calls. You made a function call in 3.cpp from a function in 2.cpp. It searches in all object files to see if actually the function exists and links that function call to the actual code of the function. That is when your file is executable. It's not just series of instructions. It's instructions that are validated that they can be executed. All right? Do we understand? And that's when you get an error message that says the function yada yada could not be found, that's the linker, not the C++ compiler. But when you get a syntax error, that's C++ compiler. Yes. Okay. The question was, could you repeat, please? Repeat the entire thing, or last 5 seconds. So what I said was that when compiler compiles individual modules, it compiles the action of calling. It doesn't guarantee that call will be successful. It just sees if you are correctly calling another function. How does it know it? From the prototype of a function. In a prototype of the function, you are mentioning function add accepts 2 integers. Good. You put 2 integers in your function call. You're good. Syntax is good. I'm going to translate your call. Puts that one in the object file. But linker, when linker actually comes to the play, it looks at the assembly code, the object file, and sees you called function add with 2 integers. Then looks to see if there is a function inside all the other object files that actually can accomplish that call. If that's the case, it links it to that place. So when the function calls, execution jumps to that function. That's what linker does. Yes? Yes. No, if you have 2 mains, if you have two mains in one file, that's compile error. But if you have one main here, then it's going to be linker error. So if you have two mains in one thing, compiler looks at two identical functions, that's a syntax error. You can't have two functions with the exact same signature. It's not overloading, right? So that gives you an error. But if you put one main function in here, another main function in another file, they are separately compiled perfectly. But when they are getting linked, it says, hey, wait a minute, you have two functions with the same name. I cannot make this an executable. I don't know where to begin. Created perfectly. But they cannot be linked together because there are two functions with the same name. Do we understand this? Okay. Why did I teach this IPC 144 thing in here? The reason is that to tell you, templates cannot have a CPP file. Because the logic needs to be available to compiler to be able to generate the function, right? If you put the logic in a CPP file and only prototype in the header file, when compiler sees your template, it doesn't know how to create the logic. There is no body. When you create a template, you are showing the logic to the compiler saying, if this function is called, please write a function for that type, right? To know that, it needs to know what the logic is. Because of that fact, when you create a module for templates, the entire code, prototype, everything must reside in a header file, not in a CPP file. Because the instruction the compiler needs to create the class requires the logic. And logic is the body of the function. You cannot put it in a CPP file because it happens in another compile. The two separate files get compiled separately. Compiler is not aware of the other compilation. There are 4 separate executions. That's why I started with that. I said when you write g++1.cpp, 2.cpp, 3.cpp, main.cpp, 4 times the compiler calls runs completely independently from each other, independent from each other. Okay? So now, now that we know this, if I actually want that sort thingy that I have written, if I want this sort thingy that I have written, is this the sort? Yes. If I want this sort thingy to be a module that I can use anywhere, what I need to do is this. I need to create, what is the time? 2:46. What I need to do over here is to create this. What do I need to create? I need to create a header file, new item, but that's going to be, because it's not an object, I'm going to make it lowercase, sorts.h, sort.h, and then I'm going to have over here, if not define, stds sort underline h, and then do define, and namespace stds, that is fine. Now I'm going to come over here and bring everything the sort needs in here, which is the swap, prototype, swap, and the sort. That print array has nothing to do with sorting, so I'm not going to put it in that module. Now I'm going to bring the entire thing in the header file, and I'm going to bring the swap down. So we have an example of prototypes for templates, so you know what they are. Do we have anything we need, everything we need in here? All the types, size T, we don't have anything special over here. There you go. So that's my sort.h. Now in this program, what I can do is say include sort.h and have all these. Container cannot be sorted. I'm going to remove it. So I'm going to say this cannot be sorted. This cannot be sorted. with sort function. Why? That's a good question for a test, to explain why. Okay. Name, I don't need that. Print array, so everything is there. I'm going to remove this. Now, I'm going to remove this. Now I have my sort header file included. Now I can actually compile and run it, and it will run perfectly. There we go. So remember, templates, entire template must exist in a header file. Are we okay down to this point? I'm going to go for 10 more minutes, and we're going to, because go 10 minutes, come back 15 minutes doesn't make sense. Okay, I'm going to continue for 10 more minutes, and then we're going to go. Okay? The template is not going to be finished. The lab that you're coming in, it's going to be lecture in it too. Okay, I'm going to continue, finish the lecture for templates over there. Yes? Because it doesn't have less than and greater than operator implement. Sort needs less than and greater than operator. I put over there why to see if you can go challenge. You asked me. Yeah, you can edit container and add less than and greater than. So let's fix that, what I just mentioned. This cannot be sorted with sort function. This cannot currently okay, be sorted. So you can change it later on. Why? That's a beautiful question for the test. Why and how? So I'm going to ask you to actually fix it and make it work with the template. All right. Next thing I wanted to mention was this. So I'm going to save this as E, and I'm going to call it sort template module. Module main 4. So going back to the add example that I have, I'm going to explain one more thing, and we're going to call it a day. The next day, if you want to study what we're going to do, we're going to talk about specialization, template specialization, and we are going to, and I'm going to teach you briefly how to have a class template, not only a function template. That's not in OOP244. In OOP244, I'll tell you what is the level for it. It's a very small example for a class template. I'm going to give you, so review the array that we created, because we're going to convert that to a template. So you can actually create an array, smart array of anything. Okay? So we're going to convert that to a template. So it's not going to be, your case was what? Float, double, what was it? A float array, double array? Nobody read it, did you? Nobody reviewed it. Double array? So double. So the double array that I created, it's going to be any array. We're going to convert it to that. Okay? So an important question is, so I have in here a template for function add. I have a template for function add. What if I had a double function? And what would happen? I have the double function, and I have the template too. What does the compiler do when I say add x and y? Now, the compiler can create a template, or it can call the overloaded function. what can be done? What is the conflict and how is it a conflict? The answer is no. There is no conflict. Always compiler says what you write supersedes what I write. So if you overload a function and there is a matching template, the template will be ignored. And your overload, because the function already exists, it doesn't want to create it. All the compiler needs to do when it wants to create the template is to check, do I already have the function? If I do, I'm not going to create the template for it. So if you have any special case that you want to handle, that you know the logic differs with what you have in your template, a bad way of doing it is to overload it. So if I have an add over here, for example, that I want to add one string to another, okay, and return the address of the string. So that's what I want to do. I want to add one string to another and return. So if I have something like this, so let's do something like this. Character pointer add, okay? Character pointer destination, character pointer source. I want to add the source to destination and return the address. Something like that. Or allocate and return it. So something very fishy, because afterwards I have to actually delete whatever it actually creates for me. If I want to do something like that, I can. Where is it? I do have the utils in here, right? So I'm going to include utils. And using namespace stds. So I can actually do something like this in here. I can say character sum or both pointer both is set to new. What do I do? I'm not going to do error checking and stuff like that. We're assuming that this is not null. So I'm not going to go into details if this destination is null, if source is null. I'm not going to do that, okay? So in here, I'm going to say new character, and in here, I'm going to say ut.strlen of the destination plus ut.strlen of source plus 1. And then I'm going to say utstr copy into both the destination. Oh, sorry, the sort. No, the destination. That's the left one. Then ut.str cat to both the source. And then I'm going to say return both. Okay? So that's kind of an add for two strings if I want to use it. So now if I actually come over here and create something like this, I'll go where do I go? What do I do? Character str Fred. Character str 2 Soleil. Then I can say character pointer both. Now in here I can say both is set to add of str1 and str2. Then I can go cout both and L, and then I can go delete, obviously, both not to have memory leak. Okay? So because I have add as double, and this one, actually I can put the double in here. Let's bring the double where it was and make commented. So now this is a bad way of adding a logic that I do not want my template to take care of, because the logic for it is different. Remember I told you that you may have the same function and two separate logics. That's the number of templates. The second one we're going to learn the next day you are coming in will be the specialization. How to specialize a specific type of template. So the bad thing about this, the reason that this is not good with respect to template is that if nobody calls that function, the function would all still exist. It will get compiled because it's not a template. With a specialization, that may be the only case the template is used because it's character pointed. But still, if you don't use it, it will not get generated. So that's the specialization we are going to talk about the next day we are coming in. I don't know if it's going to compile over here. Let's actually check it out. Yeah, it worked. Okay. Questions? Suggestions? Yes. Oh, can you have two different types over there? So the question is that in the template we have type add, type A, type B. Could I have type add, type 1A, type 2B? And then I have over the template type, comma, type 1, type 2. The answer is yes. The template is already very complicated to make. Having a multiple type template and the issues it is going to create when the template wants to get invoked. Because when you have two different types, just imagine the variety of ways it can be called. It becomes extremely complicated. We're going to learn later on how it's going to be. We're going to teach that, but avoid doing it for now. It's too rich for our blood at the moment. I'll teach you how to pass a regular value to a template. You can do that. You can say, I want type name type and an integer, which means I want to pass a type and I want to pass an integer to my template with a value. You can do that. But it's better for now to stick only to one type. It could be more than one, but let's not think about it. It's way too complicated. Okay? Anything else? Question 1. Oh, can I put the what for final test? What do I do? What is that? I didn't understand. No, it's not going to be on paper. It's going to be on computer. You want to have it on paper? Oh, reference sheet. Sure, we can do that, sure. But then you have to hand it to me at the end of the test. Yeah, sure, reference sheet, you can do that, no problem. Okay. And I'm going to create a mock-up test for you so you can do it, to get used to it, how it's done. And I'm going to give you the instructions. So to answer to that question, when you are doing your test, you are not only opening one browser. You're going to open two programs. So you have to prepare your computer. You have to open one browser. And from My Apps, you have to install Notepad++. OK? I'm going to look at the new Blackboard setting to see. I'm going to actually design the test, try to do it myself. See if the editor for the programming is good. Does it have syntax highlighting and all this stuff? It is extremely important for me, and I'm going to give you guidelines on it, on how to put information inside the text box for programming that you're writing. Okay? The reason that I'm going to ask you to install Notepad++ and write your answer in there, then copy and paste, is because I want it to be nicely organized so it can be marked. Yes? You're not going to have that thing anymore because I'm going to give you a notepad. You're going to write the answer in the notepad. When you're satisfied, you copy. Then you go over there, you paste. For what? Yeah, it's gonna be, yeah. I'll give you an exact description of what the questions are, not, no, how the questions are and what type of questions they are. So you will know that.
Because last time, the beat time, we lost a lot of time because he kept typing it in randomly, we jumped somewhere and then we start writing somewhere.
No, it's not gonna, I'm not gonna.
It's the first time we had online. Now you had it on paper.
Yeah, so that's why I'm gonna ask you to open 2 applications. And I'm gonna check on the thing to make sure only 2 applications are open. You cannot open, if the third one is open, that's gonna be considered cheating. Be extremely careful. If you open anything even for a second, it's gonna flag you. So you have to have 2 applications open. One is the test, and the other one is Notepad for your rough work. So you can do it, and I'm not gonna accept any code that is messy, which means if you just write in one line, if you do not indent, if you put extra spaces for no reason, I'm not gonna mark it. You have a text editor, write it clean. That's all I'm asking. Have proper indentation, do things properly, and do it. Don't just write garbage over there, okay? And another thing that is going to be extremely important is relevance, which means the answer you're going to give to the test, to the question, must answer the question. If it doesn't answer the question and it's a perfect thing, you're not going to get any mark. An example for it is, if I ask you to create a class for a student, you create a perfect class for an employee, you get 0, even if it's perfect. That prevents copy and pasting or copying from your cheat sheet, from your reference sheet. Okay? So I want you to, that's the only 2 rules that I have. It needs to be organized properly and relevance. That's all. The rest is fine. I might give you some explanation to do. Right? For example, I told you I'm going to give you a piece of thing and I'm going to say why this thing doesn't work. You have to explain it to me in English. Okay? Debugging you are doing in walkthroughs anyway. So how many errors is this? Like find an error inside this code? I don't know if I'm going to give you that question or not. So you're going to have enough walkthroughs to go through. And you're going to have multiple choice. You're going to have a couple of explanations to do and programming. These are the things that are going to be most likely. You'll see. Any questions before we leave? All right.